again, welcome back. This is Great Math number 13. Today, we're going to do really interesting and complex problems today. Okay, so let's go. So, it's a series, okay? It's a series of numbers, sorry. This pen might not be working. Sorry about that, okay? So basically is, what two different reciprocals, you know what a reciprocal, what two reciprocals of a number, let me repeat, what two different positive integers whose reciprocals sum to a fraction. So for A,
read it well.
It's going to be 1/2.
Read it well.
That sum to 1/2. So basically, it's find two different positive integers whose reciprocals sum to 1/2.
Oh, that's very good.
So today we're going to do 1/2. So this one's going to be 1/2. And we're going to have others. So 1/3, 1/4, 1/5, 1/6, and the last one I can't say until we're done because then you guys are going to be stressed before we even start. Okay. Well, actually, you guys are already stressed. Okay, sorry. So what is a reciprocal anyway? A reciprocal, okay, let's say, since 13, let's use 13. The reciprocal of 13 is basically 1/13. See, if you put a 1, but if you were trying to look for a reciprocal of a number, so 1/13, its reciprocal is 13/1, or 1/13 by the power of -1. Okay? So let's do this. So 1/2. Remember, it's two different positive integers. So obviously, since we can't use, even that means 4, we can't use it because 4 reciprocal would be 1/4, 1/4 plus 1/4. Obviously, it's 1/2, but we can't use that. So what do we use? We can use 1/6. It's 3/6 is equal to it. Wait a second, we see something. 3/6, okay. Isn't 1/3 2/6? So if we use 1/6 and 1/3, which is 2/6, that would equal to 3/6, which is equal to 1/2. But those are fractions, so that means it would be 3 and 6. So we already have our answer for A. So it's equal to 1/3 plus 1/6. So basically, it's 3 and 6 is our answer for A. See, now we get it, okay? So let's do 1/3. Well, we can try 1/12. Again, wait a second, before we start this, okay, you see our answer here would have been 2 and 3. So 2 times 3 equals 6. That's a coincidence. Another try, it's just a copy. But 3 times in a row, then that's for sure. Okay? So if you're not completely sure. So then let's use it right now. So basically, well, let's try 1/12. If we use 1/4, that's basically 3/12, which equals to 4/12, which is equal to 1/3. So that works. Again. So yeah, that might be right. So 1/4 plus 1/12. So basically that's 4 and 12. Okay? So if this one is correct, then that means for sure this technique that we've been using will work. So let's see. 4 times. So this one, if you can see here, 2 times 3, which is the next one, would equal. So the next one kind of helps, and the next one kind of helps with the first one. So yeah, that's pretty easy. That's pretty smart for us. So 1/4. So let's try 1/20.
Why 20?
1/20 because 4 times 5, which is equal to 20. Because, like we said, it's kind of like this. So if we're going to use it here, then that actually might work. Let's see. Let's double check. What if we use 1/12 again? No, that wouldn't work. Because if you use 1/5, then no, that wouldn't equal to 1/4. So yeah, so let's try 120. And so that's 120. We would need four more for it to be 520, and then that would equal to 1/4. But 1/5 is equal to 4/20s. So that's great. So we can use 1/5, which is, that makes our answer right here. So now that's for sure. So it's just a copy, coincidence. Now that's for sure. So that means, okay, so let's use the easy way out this time. 5 times 6, that'd be 1/30. And then let's use 1/6. So we would need 5 more. So that would be 5/30. Yeah, that would work. So 1/6. So that equals to 6 and 30, all of their reciprocals. No, 6. Well, we don't have this next one, but the next one would have been 1/7. Don't you think? Because we're going in number order. So 1/7. 7 times that would equal to 1/42. And if we use, so then we would need 6 more. We would need 6 more, which then that would work. So 1/7, because that's 6/42, and that would be 7/42, which is equal to 1/6, which is 7/42.
So what did we find here? We found
So
the sum of two integers that equal
to the fractions here.
Oh, okay, different, distinct integer.
Yeah,
Okay.
different. Because remember the book's challenge questions specifically state that they have to be different. Because if they weren't different, you would have found those very easily. But too bad it ain't. It's not. Because basically you just do half of 1/2. That's 1. That would be 2/6. Yeah, that'd be easy. But the book does not want us to do easy things. So that's why it's 2 different ones. Okay, guys. Okay. Now for the last one. You guys will be stressed. But just take it easy, okay? Just stay with me, okay? Let's let n be a positive integer. What 2 different positive integers in terms of n whose reciprocals sum to 1/n? Now that, you guys are like, whew. But just stay with me. You will understand why it's easy. It could be easy, it could be hard. This one was one of the challenging ones. But so come on, let's go. So 1/n. Well, let's see. We don't know what's the number before 1n, which is equal. The only number would be 1/n minus 1. So that'd be the number. But then we don't know where on the number line that is. That could be humongous, that could be very tiny. We don't know. So, but let's just give it a try. So basically all we know is basically plus 1 from the denominator of each number. We can see that. It says 2, add 1 to the denominator, 3. 3 to the 4, 4 to the 5, 5 to the 6, 6 to the 7. Okay. So it's pretty easy. So then we'll use that. n plus 1. Then that means, and as you can see here, the next ones, it's basically the 2 numbers multiplied to make the next number. 3 times 4, 12. 4 times 5, 20. That's interesting. So we kind of see a pattern here. So then that might help us, that just might help us find the rest of f, the very hard question. So that means n times n plus 1. So that would be n parentheses n plus 1. Okay, let's crank up this thing. So we're not sure. This could be, this could not be. Okay. is equal to, so basically, first, before we do an addition one, we have to make these fractions even. So basically, you would have to do n times n plus 1, and this would be n times 1. So it's equal to n times 1 over n plus 1 plus 1 over n parentheses n plus 1. So now they're even. So what is that? Then that's n times 1 plus 1 over n parentheses n plus 1. So basically that's what it is, which is equal to, which then that would be equal to, then that'd be equal to n times n. Then it'd be
10 times 1 equal what?
n times 1.
Wait a
second. And we can use the canceling property. 18
okay.
times 1.
Okay.
It's in they're both in parentheses. They're both n plus 1.
And they're both positive. Yeah.
Yeah, although the rule states you can't do plus. But that doesn't necessarily mean if you're taking this chunk with this chunk. That only would mean if this multiplication was addition. Then you can't do that. But since it's a multiplication, we can. So we cancel these out. And there can't be anything here, so there always has to be a 1 after that, which equals to 1 over n. So the sums of these two would work. So that means it's n plus 1 and n times n plus 1. So these are the two positive integers that we needed, whose reciprocals are equal to n. So there we go. Voila! That's where it is. So today we just learned something extremely interesting and at the same time really hard. Hopefully I hope you guys paused and then like, okay, what is this? Okay, JP said this problem, yeah. So I hope you guys really do this. So then you guys can see how hard it is without even knowing my steps. So, for next time, I'm Jean-Pierre and this is Great Math. See you next time. Bye.